All right, more with factoring and solving and synthetic division. Now, a quick reminder, when you're using synthetic division, you want there to be no remainder if possible. So we have our x plus 5, which remember that's x is equal to a negative 5. So we have a negative 5, big ol' L for Longo, 1, 7, 0, negative 49. Drop your 1. We have a negative 5, which will give us a 2, negative 10, which is negative 10, and then we have our 50, which leaves us with the remainder of 1, and that's bad. So, just wanted to quickly remind you that when you're using synthetic division to factor, remainders are bad. So, when we're going to factor these, and I don't give you a 0, what are you going to do? Well, there's a couple of things you can do. And one of them is use the rational root theorem. And what you do there is you first have it organized, and you're going to list all of your possible factors of your first term and your last term. So if we were to arrange this all alphabetically, this would be our P, and this is going to be our Q when we're done for division purposes. Okay, where what we're going to do is, what are our factors of 3? 3 and 1. What are our factors of 2? 2 and 1. And then what you do is list every possible combination, and what we're going to do here is list plus or minus. We have 3 halves. We have plus or minus 3 over 1, which is just 3. Then we have our 1, so we do plus or minus 1 over 2. And then we have our plus or minus 1 over 1, which is 1. We list all the possible combinations where we take our last term divided by our first term. So as you see here, we have 8 different possibilities of zeros, or something that will work using synthetic division. So what you would do is you would try to divide 2, negative 1, negative 1, negative 3 by a 1. And if that didn't work, then you try a negative 1. If that didn't work, then you try a negative 1/2. If that didn't work, you'd try a positive 1/2. And you would keep on guessing until you got one that has no remainder. Sounds like a lot of fun, right? So if you look to the right, we have a graphing calculator. I would get it because I'm going to show you how to eliminate all of that guessing and checking. Okay? But that's how you would do it if you found yourself in a unique situation where you did not have a graphing calculator with you and all you had was a little calculator or no calculator at all. So, what you see here is the same thing we were just working with. So we need to list all the rational roots. We're going to factor completely, and we're going to find all the zeros. So our possibles, as you remember from above, are plus or minus, and we had 3, we had 1, we had 3 halves, and we had 1/2. All of them plus or minus. Now, use your graphing calculator to find one of them that you know is going to work for sure before you do synthetic division. So let's click y equals, and then you're going to enter in your 2x cubed minus x squared minus x minus 3. And you just graph it. And you try to find one that looks like you have a root. So you only have one possible root out of all of these because it only crosses the x-axis one time. It's pretty easy to see what your only root is going to be from this list. It's not going to be plus or minus 3, not going to be plus or minus 1, it's not going to be plus or minus 1/2. It looks like the only one is a positive 3 halves. So what you get to do is you get to go use synthetic division with 3 halves. So we bring down our 2. 3 halves of 2 is going to give us 3. and that'll give us another 2, and that's going to give us another 3, which is going to give us another 2, and that's going to give us a 3, which is going to give us no remainder. We are good. So that factored to 2x squared plus 2x plus 2. I'm pretty sure you can see that you can factor out a 2 here, and that's going to give us this guy right here. So you can't factor the inside, so we're just going to leave that alone. And you can't forget about this guy over here. So we have a GCF of 2. So what you think you have factored is 2, and then you have your x squared plus x plus 1, and then you have your x minus 3/2, because you can't forget about this guy that you found. And we don't usually write this in factored form. So look, if you were to bring this 2 and multiply them inside there, it'll get rid of your fraction. So your final completed factored answer for part B is 2x minus 3 times x squared plus x plus 1. And then finally in part C, you have to solve. To solve, obviously you know one of your answers is going to be 3/2, because we already found that with the calculator. The other one you are going to have to use completing the square, quadratic formula, whatever you want. So we're going to have an opposite of b plus or minus a big ol' square root of b squared minus 4 times 1 times 1 all over 2 times 1. So that's a -1 plus or minus, and looks like we have the square root of a -3 all over 2. So that's going to give us x is equal to a -1 plus or minus I root 3 all over 2. And those are your solutions for x. Again, if you have your graphing calculator, you can use it to find just the first 0. And then you use synthetic division and factor and all that stuff. Actually, you could use your calculator in a very slick way to double check all of them if you would like. Okay? But as you see, only one of them crossed the x-axis, so only one of them is real, and the other 2 are imaginary because, well, this could be x cubed and only cross the x-axis once. Alright? So go ahead and pause the video, try number 3 on your own. So, there's a chance that you have the exact same answers as me in part C, but your part B might look a little different. And that's because if you used your graphing calculator, you would have found that there are 3 real numbers because the graph crosses the x-axis 3 times. So all you had to do was pick one of those roots to use synthetic division. So I picked the -2 right here, but you might have also picked the -1/2, or you might have picked the 4. It doesn't matter. As long as you use your graphing calculator to get one, your factoring should end up the same and your answers will end up the same. It's just that the synthetic division part is a little bit different. Alright, so there's only one more example here. Go ahead and try number 4. Again, use your graphing calculator to get the first root. It's a little bit bigger, so you can have up to 4 roots here, real or imaginary. So go ahead and give it a try. If you got x equals -2, 1/3, and 1 plus or minus root 2, you are correct. Now, if you did it the same way I did, once you got to this step right here, you would have noticed that it cannot be factored. So you had to use synthetic division again. So what you do is you just type it back into the graphing calculator, find another 0 to work with, and then just continue factoring. You get your synthetic division, factor out 3, make sure you put it in here so you don't have a fraction in your factored answer, and you're good right here. These 2, easy to solve. This one, you had to use quadratic formula or completing the square, and you're good to go. That's it for this lesson. Remember, factoring completely means take it as far as it can go. Solving means find all the zeros. Listing possible roots, that's where you just have to do the plus or minus p over q just to list the possible. But you do not need to guess and check. use your graphing calculator. This is Longo, and I'm out. See you, bye.